Hello, in this lecture we will find out the value of angle x using two different methods. In the drawing we have triangle QPR. We know that QS equals to SR. We also know that angle PSQ equals to 45 degrees. Angle PQS equals to 3x. And angle PRS equals to x. And we want to find out the value of angle x. So we'll start with the first method. In the first method, we will define angle QPS as alpha and angle SPR as beta, and we will find out the value of angle PSR. We define this angle PSR as y, and we know that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on the upper side of the straight line QR at point S, then the sum of the angles at point S at the upper side of QR must be equal to 180 degrees. That is to say 45 degrees plus angle Y must be equal to 180 degrees. Here we will subtract 45 degrees from this equation, and we will find out that angle Y equals to 180 degrees minus 45 degrees is 135 degrees. So we found out that angle Y equals to 135 degrees. So we can substitute here angle Y by 135 degrees. In the next step, I will present to you a new rule. It is actually the law of sines. The law of sines is true in any triangle. So we can write down that in any triangle, if we have a triangle and we know that the length of this side is A units, the length of this side of the triangle is B units, and the length of this side is C units, and we also know that this is angle A, this is angle B, and this is angle C. Then, according to the law of sines, A over sinus A equals to B over sinus B equals to C over sinus C. I will repeat again. In any triangle, A over sinus A equals to B over sinus, this is actually B, and this is C, so I will repeat again. In any triangle, A over sinus A equals to B over sinus B equals to C over sinus C. From this formula, we can derive that A over sinus A equals to B over sinus B So here we will divide this equation by B, and we will multiply it by sinus A, and we will get that A over B equals to sinus A over sinus B. A over B equals to sinus A over sinus B. So what is the meaning of this equation? The meaning of this equation is that the ratio between the side lengths of any triangle or the ratio of the side lengths of any triangle is equal to the ratio of the opposite angles. So I repeat again. The ratio of the side lengths of any triangle is equal to the ratio of the opposite angles. Okay? So now we will return to our original drawing. In our original drawing, we will create equation number 1 that states that PS over SR equals to PS of PS over SR equals to PS over QS. Or you can also write that PS over QS equals to PS over SR. And equation number 1 is true because of the fact that QS equals to SR. QS equals to SR. So according to the equation that A over B equals to sinus A over sinus B, we will get that PS over QS is equal to sinus 3x over sinus alpha the ratio between the side lengths is equal to the ratio of the opposite angles, and we get that PS over SR, if we focus on triangle PSR, it equals to sinus x over sinus beta. So we got the equation that states that sinus x over sinus alpha equals sinus 3x over sinus alpha equals to sinus x over sinus beta. And we also know that the sum of the angles in any triangle is equal to 180 degrees. That is to say, if we focus on triangle PQS, the sum of its angles must be equal to 180 degrees. It means that alpha plus 3x plus 45 degrees must be equal to 180 degrees. I repeat again, in triangle PQS, the sum of the angles must be equal to 180 degrees. That is to say, alpha plus 3x plus 45 degrees must be equal to 180 degrees. Here we will subtract 3x and also 45 degrees from this equation number 2. And we will get that according to equation number 2, alpha equals to 180 degrees minus 3x plus 45 degrees I repeat again, we subtracted 3x and also 45 degrees from this equation number 2, and we got that angle alpha equals to 180 degrees minus 3x plus 45 degrees. So we actually succeeded to express the value of alpha in terms of x. Likewise, in triangle PSR, the sum of the angles must be equal to 180 degrees. That is to say, beta plus 135 degrees plus x must be equal to 180 degrees. I repeat again, in triangle PSR, the sum of the angles must be equal to 180 degrees. That is to say, beta plus 135 degrees plus x must be equal to 180 degrees. Here we will subtract 135 degrees and also x from this equation number 3, and we will get that beta equals to 180 degrees minus 135 degrees is 45 degrees, and also we subtracted x, so it is 45 degrees minus x. So we found out that according to equation number 2, angle beta equals to 45 degrees minus x, and we also found out that angle alpha equals to 180 degrees minus 3x plus 45 degrees. Okay, so now we can substitute angle alpha and beta in this equation, equation number 1, by the values that we found in equation number 2 and equation number 3. So we will do it now. We will get that according to equation number 1, sinus 3x over sinus alpha, and alpha equals to 180 degrees minus 3x plus 45 degrees according to equation number 3, and it equals to sinus x over sinus beta, and beta equals to 45 degrees minus x according to equation number 2. So here we substituted alpha and beta in this equation, equation number 1, by the values that we found in equation number 2 and equation number 3, and we got this equation. We know that we have the trigonometric identity that states that sinus 180 degrees minus theta equals to sinus theta. So according to this trigonometric identity, we will get that sinus 180 degrees minus 3x plus 45 degrees equals to sinus 3x plus 45 degrees. So now we will substitute sinus 180 degrees minus 3x plus 45 degrees by sinus 3x plus 45 degrees that we found according to this trigonometric identity. So we will get that sinus 3x over sinus 3x plus 45 degrees equals to sinus x over sinus 45 degrees minus x. So here we will cross multiply equation number 1, and we will get that sinus 3x times sinus 45 degrees minus x equals to sinus x times sinus 3x plus 45 degrees So here we will multiply equation number 1 by 2, and we will get that 2 sine 3x sine 45 degrees minus x equals to 2 sine x sine 3x plus 45 degrees. Here we will use the trigonometric identity that 2 sine A sine B equals to cosine A minus B minus cosine A plus B. In our expression, A equals to 3x and B equals to 45 degrees minus x, and actually, according to this trigonometric identity, 2 sine A sine B, 2 sine A sine B equals to cosine A minus B. So here cosine A minus B will be equal to cosine 3x minus x is 3x plus x, that is to say 4x, and 0 minus 45 degrees is minus 45 degrees, and we also must to subtract cosine A plus B. Here A is 3x and B is 45 degrees minus x, so A plus B will be equal to 3x plus minus x is 3x minus x, 3x minus x is 2x, A plus B, so it is 0 plus 45 degrees is plus 45 degrees. So we actually finished to treat this expression. Now we will treat the other side of equation number 1, and we will get that here A equals to x and B equals to 3x plus 45 degrees, and 2 sine A sine B is cosine A minus B, so cosine A minus B, A is x and B is 3x plus 45 degrees, so A minus B is x minus 3x is minus 2x, and 0 minus 45 degrees is minus 45 degrees. So it is, we got 2x minus that this expression 2 sine x sine 3x is cosine A minus B, and cosine A minus B, it is actually cosine minus 2x plus 45 degrees. But because of the fact that cosine minus x equals to cosine x, we cannot actually change the sign of minus in our expression to plus, so it will become cosine 2x plus 45 degrees. The negative sign will turn into positive according to this trigonometric identity. We will get cosine 2x plus 45 degrees, and we also must to subtract minus cosine a plus b. Here a plus b, a is x and b is 3x plus 45 degrees. A plus b is x plus 3x is 4x plus 0 plus 45 degrees is 45 degrees. Okay, so here what we have here in equation number 1, we have cosine 4x minus 45 degrees and we also have minus cosine 4x plus 45 degrees. So we will add to this equation number 1, cosine 4x plus 45 degrees. So here we added to this side of equation number 1, cosine 4x plus 45 degrees. So we got here cosine 4x plus 45 degrees. And when we add cosine 4x plus 45 degrees minus cosine x plus 45 degrees is 0. And here we have minus cosine 2x plus 45 degrees. So we will add to this equation number 1, cosine 2x plus 45 degrees, and cosine 2x plus 45 degrees plus cosine 2x plus 45 degrees will be equal to 2 cosine 2x plus 45 degrees So actually cosine 4x minus 45 degrees plus cosine 4x plus 45 degrees is very similar to the trigonometric identity of cosine C plus cosine D. We have the trigonometric identity that states that cosine C plus cosine D is equal according to this trigonometric identity, cosine C plus cosine D equals to 2 cosine C plus D over 2 times cosine C minus D over 2. So we will use this trigonometric identity in order to simplify this cosine C plus cosine D equals to 2 cosine C plus D over 2 times cosine C minus D over 2. And we also have the expression 2 cosine 2x plus 45 degrees, 2 cosine 2x plus 45 degrees is very similar to the trigonometric identity that states that cosine A plus B equals to cosine A cosine B minus sine A times sine B. So we will use this trigonometric identity in order to simplify the expression 2 cosine 2x plus 45 degrees. So we will start with the first part of equation number 1, that is actually cosine 4x minus 45 degrees plus cosine 4x plus 45 degrees, and we will deal this expression according to the trigonometric identity that states that cosine c plus cosine d equals to 2 cosine c plus d over 2 times cosine c minus d over 2. Here, actually c equals to 4x minus 45 degrees and d equals to 4x plus 45 degrees. So according to the trigonometric identity that cosine c plus cosine d equals to 2 cosine c plus d over 2 times cosine c minus d over 2, we will get that in our specific expression cosine 4x minus 45 degrees plus cosine 4x plus 45 degrees, it equals, according to the trigonometric identity, it equals to cosine c plus d over 2. So we know that c is 2 cosine c plus d over 2. C is 4x minus 45 degrees and d is 4x plus 45 degrees. So c plus d is 4x plus 4x is 8x, and 8x over 2 is 4x. And minus 45 degrees plus 45 degrees is 0. Then, according to this trigonometric identity, we must also multiply our expression by cosine c minus d over 2. Cosine c minus d over 2. C minus d, 4x minus 4x is 0, and minus 45 degrees is minus 90 degrees, and minus 90 degrees over 2 is minus 45 degrees. So we get minus 45 degrees, but because of the fact that cosine 45 degrees equals to cosine minus 45 degrees, we will change the negative sign to a positive sign, and we will get cosine 45 degrees. Then we will deal in the second expression that is actually the second expression is 2 cosine 2x plus 45 degrees. So here we know that A equals to 2x, B equals to 45 degrees, so cosine x plus 45 degrees, it is actually cosine A plus B, that is actually cosine A times cosine B minus sine A times sine B, and we will get that cosine A plus B equals to cosine A cosine B minus sine A times sine B. Okay, and wrote it here that cosine A plus B equals to cosine A cosine B minus sine A times sine B. So cosine A is cosine 2x times cosine B is cosine 45 degrees minus sine A sine B minus sine A is sine 2x, A is 2x, times sine B, that is sine 45 degrees. Okay, so here we will divide equation number 1 by 2 cosine 45 degrees. So here 2 cosine 45 degrees will get cancelled. And here also 2 cosine 45 degrees will get cancelled. And here we will cancel 2 sine 45 degrees because of the fact that cosine 45 degrees equals to sine 45 degrees. And we will get that according to equation number 1, cosine 4x equals to cosine 2x minus sine 2x. Okay, so actually, according to equation number 1, we got that cosine 4x cosine 4x equals to cosine 2x minus sine 2x. Here we will add to this equation, equation number 1, sine 2x, and we will subtract cosine 4x, and we will get that sine 2x equals to cosine 2x minus cosine 4x. We actually know that sine 2x equals to 2 sine x cosine x, and cosine 2x minus cosine 4x, it is very similar to trigonometric identity that states that cosine C minus cosine D, cosine C minus cosine D equals to 2 sine D plus C over 2 times sine D minus C over 2. Okay, we will find the value of cosine 2x minus cosine 4x according to this trigonometric identity. So, in our specific expression, cosine 2x minus cosine 4x, C equals to 2x and D equals to 4x. So actually 2 sine D plus C over 2 is 2x plus 4x, that is 6x, and 6x over 2 is 3x. And we also must multiply it by sine D minus C over 2. d minus c is 4x minus 2x, that is 2x. 2x over 2 is x. So we will multiply it by sine x. Okay? So here we will divide this equation number 1, by 2 sine x. And we will get that cosine x equals to sine 3x. Okay. But according to the trigonometric identity, that cosine x equals to sine 90 degrees minus x, so we can substitute cosine x by sine minus 90 degrees, sine 90 degrees minus x, according to this trigonometric identity. So we'll do it and we'll get that cosine x equals to sine 90 degrees minus x, and it equals to sine 3x. So sine 90 degrees minus x equals to sine 3x means that 90 degrees minus x equals to 3x. Here we will add x to this equation and we will get that 90 degrees equals to 3x plus x is 4x. We will divide this equation by 4 and we will get that x equals to 90 degrees over 4. 90 degrees over 4 is 22.5 degrees. So we found out that angle x equals to 22.5 degrees. So we finished with the first method. In the next step, I will present to you how to find out the value of angle x according to the second method. So, in the second method, we will define angle QPS as alpha and angle SPR as beta, as we did in the first method. We have already found out that angle PSR equals to 135 degrees in method 1. And we also note that the sum of the angles in any triangle is equal to 180 degrees. So if we focus on triangle QPS, then we know that the sum of its angles is equal to 180 degrees. That is to say, in triangle QPS, alpha plus 3x plus 45 degrees must be equal to 180 degrees. I will repeat again. According to the rule that the sum of the angles in any triangle is equal to 180 degrees, we will get that the sum of the angles in triangle QPS must be equal to 180 degrees. That is to say, alpha plus 3x plus 45 degrees equals to 180 degrees. And here we will subtract 3x and also 45 degrees from this equation, equation number 1, and we will get that actually we will subtract only 45 degrees from equation number 1, and we will get that alpha plus 3x equals to 135 degrees, because 180 degrees minus 45 degrees is 135 degrees. Then in triangle PSR, the sum of the angles must be equal to 180 degrees. That is to say, angle beta plus 135 degrees plus angle x must be equal to 180 degrees. I will repeat again. In triangle PSR, the sum of its angles must be equal to 180 degrees. That is to say, angle beta plus 135 degrees plus angle x must be equal to 180 degrees. Here we will subtract 135 degrees from this equation number 2, and we will get that angle beta plus x, according to equation number 2, is equal to 180 degrees minus 135 degrees is 45 degrees. So here we will multiply equation number 2 by 3, and we will get that 3 beta plus 3x equals to 45 degrees times 3 is 135 degrees. And according to equation number 1, alpha plus 3x also equals to 185 degrees. So here you can see that equation number 1 is equal, and also equation number 2, both equations are equal on this side of the equation to 135 degrees. So we can say that equation number 1 equals to equation number 2, so we create equation number 3 that states that 3 beta plus 3x, according to equation number 3, according to equation number 2, that equals to 135 degrees, must be equal to alpha plus 3x, that also equals to 135 degrees. So here we will subtract 3x from this equation number 3, and we will get that alpha equals to 3 beta. Alpha equals to 3 beta. We found out that alpha equals to 3 beta according to equation number 3. In the next step, we will do a construction from point Q. We will draw a straight line to PR in such a way that the angle that will be created here will be equal to x. I repeat again. We drew the straight line from point Q in such a way that this angle will be equal to x. We will define the touching point between the straight line from point Q to PR as point M. Triangle QMR is an isosceles triangle because it has two angles that are equal to each other. They are both equal to x degrees. And the base of the isosceles triangle QMR is QR. We will join points M and S together by a straight line. So here MS is the median to the base of the isosceles triangle QMR. The median to the base bisects the bases, and as you can see, indeed the median MS bisects the base because of the fact that QS equals to SR according to what is given in the question. But according to rule number 3, the median to the base to an isosceles triangle, it is not only bisects the base, but it is also perpendicular to the base. That is to say, the median MS is perpendicular to the base. That is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees. According to the rule that the median to the base of an isosceles triangle is perpendicular to the base, so say this angle equals to 90 degrees and this angle also equals to 90 degrees. In the next step I will present to you a new rule, rule number 4. According to rule number 4, an exterior angle of a triangle is equal to the sum of the two angles that are not adjacent to it. That are not adjacent to it. So I read rule number 4 again. According to rule number 4, an exterior angle of a triangle is equal to the sum of the two angles that are not adjacent to it. So what is the meaning of rule number 4? The meaning of rule number 4 is that if we have triangle ABC, that could be any triangle, this is triangle ABC, and we know that the interior angles of triangle ABC are alpha, beta, and gamma. Again, alpha, beta, and gamma are the interior angles of triangle ABC. Triangle ABC has also an exterior angle. Actually, angle SAB, this angle is defined as an exterior angle, and according to rule number 4, an exterior angle of a triangle, that is to say angle SAB, is equal to the sum of the two angles that are not adjacent to it. Angle gamma is adjacent to angle SAB, and the other two angles that are not adjacent to it are alpha and beta. And according to rule number 4, the value of the exterior angle SAB is equal to the sum of the two angles that are not adjacent to it. That is to say, it equals to alpha plus beta. Okay, it is true in any triangle that the value of the exterior angle equals to the sum of the two angles that are not adjacent to it. In this case, it is alpha plus beta. So, the exterior angle SAB equals to alpha plus beta. We actually can implement rule number 4 in our drawing, because in our drawing we have the isosceles triangle MQR, and those two angles and also this angle are defined as the interior angles, and angle PMQ, this angle is defined as an exterior angle of triangle QMR. And according to rule number 4, the value of this exterior angle equals to the sum of the two angles that are not adjacent to it. And the two angles that are not adjacent to it is those two angles, and the sum of those two angles is x plus x, that is 2x. So the value of the exterior angle PMS will be equal to 2x. And here we actually know that angle PQS is equal to 3x. Angle MQS equals 2x. So this angle will be the difference between 3x and x. That is to say, it will be equal to 3x minus x, that is to say, it will be equal to 2x. Because x plus 2x must be equal to this 3x. X plus x must be equal to 3x, therefore angle PQM must be equal to 2x. Okay? So we actually found out that those two angles, they are both equal to 2x. Therefore, triangle PQM is also an isosceles triangle. And we know that in an isosceles triangle, in front of equal angles, there are equal sides. So those two sides, that is actually PQ and PM, that are located in front, those two equal angles must be also equal to each other. That is to say, PQ equals to PM. So we found out that PQ equals to PM. Okay? In the next step, I will draw perpendicular from point P to QM. So this angle equals to 90 degrees, and this angle also equals to 90 degrees. And then I will extend the perpendicular from P until it touches QS, and we will define the touching point between the perpendicular from point P to QS as point N. We will define the touching point between the perpendicular from point P to QM is point L. Then we will focus on those two right triangles. So we will focus on triangle PQM, this right triangle, and triangle PLM, this right triangle. So here in those two triangles, we know that those two angles are equal to each other, they are both equal to 2x. So angle PQL, angle PQM of triangle PQL equals to angle PML, and both angles are equal to 2x. I'll repeat again. Angle PQL equals to angle PML equals to 2x. And we also know that those two angles, they are both equal to each other, they are both equal to 90 degrees. So angle PLQ equals to angle PLF, this angle, and both angles are equal to 90 degrees. Angle PLQ equals to angle PLM equals to 90 degrees. And the first pair of angles, those two angles must be also equal to each other according to Ferdinand theorem. So angle QPL must be equal to angle MPL and those two angles are equal to each other according to Ferdinand theorem. I repeat again. Angle QPL equals to angle MPL and they are equal to each other according to Ferdinand theorem. So what is Ferdinand theorem? Ferdinand theorem is that if two angles in one triangle can go to two angles in another triangle, then the first pair of angles must also congruent. Why? Because it is complementary to 180 degrees. The value of the third angle is equal to 180 degrees minus the sum of the two other angles, and the sum of the two other angles are equal in both triangles. They have the sum sum of the two angles, because the two angles are also equal to each other, so therefore their sum will be also equal to each other. That is to say, the value of the third angle is equal to each other according to Ferdinand theorem. Okay? And so, because of the fact that those two angles are equal to each other, those two angles, if we define this angle as theta, if this angle equals to theta, then this angle also must be equal to theta, because of the fact that those two angles are equal to each other. This angle must be also equal to theta. From the drawing, it is very easy to see that theta plus theta equals to alpha plus beta. I repeat again, theta plus theta equals to alpha plus beta. You can see from the drawing easily that theta plus theta equals to alpha plus beta. Theta plus theta is 2 theta, and it equals to alpha plus beta. So we got that 2 theta equals to alpha plus beta, but according to equation number 3, alpha equals to 3 beta. So we can substitute alpha in this equation by 3 beta. We will do it and we will get that 2 theta equals to alpha is 3 beta plus beta. 3 beta plus beta is 4 beta. So we got the 2 theta equals to 2 beta. We will divide this equation by 2 and we will get the theta equals to 2 beta. So we found out the theta equals to 2 beta. Here, angle theta equals to 2 beta. We write it down. And then also angle theta equals to 2 beta. But it is very easy to see from the drawing that the value of angle L theta in the red color minus angle beta will be equal to this angle. So angle theta is 2 beta. 2 beta plus beta equals to angle NPS. So we found out that angle NPS equals to beta. This angle NPS equals to beta. And likewise here we have angle MSN that equals to 90 degrees. So if we subtract from the right angle this angle PSN that equals to 45 degrees, we will get the value of this angle MSP. So the value of angle MSP equals to 90 degrees minus 45 degrees. That is to say it equals to 45 degrees. We found out that angle MSP equals to 45 degrees. In the next step, we will prove that triangle PNS is congruent. Triangle PNS, this triangle is congruent to triangle PMS. So I will draw out those two triangles again in a new page, and in this way we see those two triangles clearly. So we have triangle PNS. So I draw those two triangles in a new page, and we actually we have to prove that the green triangle PNS is congruent to the white triangle PSM. I write it down that the green triangle PNS congruent to the white triangle PSM. So why they congruent to each other? First of all, those two angles, first of all, PN equals to, actually those two angles, they are equal to each other. They are both equal to beta, so angle PNS of the green triangle is equal to angle SPM and both angles are equal to beta. I'll repeat again. Angle PNS of the green triangle is equal to angle SPM of the white triangle, and both angles are equal to beta. And we have also angle NSP is equal to angle MSP, and both angles are equal to 45 degrees. Angle NSP equals to angle MSP equals to 45 degrees. And PS is a common side, it belongs to both triangles, so we can write down that PS equals to PS as a common side that belongs to both triangles. So we actually proved that the green triangle is congruent to the right triangle according to angle side angle rule. So the green triangle PNS congruent to the white triangle PSM according to angle side angle rule. So what is angle side angle rule? Angle side angle rule is that if you prove that two angles and the side that is included between them congruent to two angles and the side that is included in another triangle, then you actually prove that those two triangles congruent to each other according to angle side angle rule. And we proved that those two angles inside PS that is between those two angles in the green triangle congruent to those two angles in the side PS that is between them in the white triangle. Then we proved that those two triangles congruent to each other according to angle side angle rule. And from the fact that those two triangles congruent to each other, we will conclude that NS equals to MS. And we also know that this angle is a right angle, it equals to 90 degrees. So we will join together points N and M by straight line. So I will draw triangle NSM again in a new page. So I draw the right triangle NSM together by a straight line. I draw triangle NSM in a new page. Triangle NSM is a right triangle because this angle equals to 90 degrees. And we also know that NS equals to MS. Those two sides are equal to each other, therefore those two angles must be also equal to each other according to the rule that in front of equal sides in a triangle there are equal angles. So in front of those two equal sides in the triangle there are equal angles. That is to say, those two angles are equal to each other. So if one angle is equal to y, then the other angle must be also equal to y. Okay? And actually y plus y must be equal to 90 degrees in order to complete the sum of the angles in this triangle to 180 degrees. So y plus y must be equal to 90 degrees. Two y equals to 90 degrees. We will divide this equation by 2 and we will get that y equals to 45 degrees. So we found out that this angle is equal to 45 degrees. Those two angles are equal to 45 degrees. Here we will also join points N and M together by a straight line. We know that NS equals to MS. We found out that angle angle MNS equals to angle MNS equals to 45 degrees, and also this angle equals to 45 degrees. In the next step, we will prove that triangle PQN is congruent to triangle PNM. So triangle PQN congruent to triangle PNM. So I will draw the two triangles in a new page and we will focus on them clearly in a new page. So here we have triangle PQN. Also triangle NMP. So we will actually prove that the green triangle triangle PQN congruent to the white triangle PNM. First of all, we know that PQ equals to PM. PQ equals to PM. PQ equals to PM. We have already found out that PQ equals to PM. Okay. And here those two angles are equal to each other, they are both equal to 2 beta. So angle QPN on the green triangle equals to angle NPM on the white triangle, and both those two angles are equal to 2 beta. And repeat again, angle QPN equals to angle NPM, and both angles are equal to 2 beta, and we also have a common side. PN is a common side, it belongs to both triangles. So PN equals to PN, it's a common side that belongs to both triangles. So we actually proved that the green triangle PQN, congruent, this is the sign of congruent, to the white triangle PNM, and they congruent to each other according to side angle side rule. I'll repeat again, we proved that the green triangle PQN congruent to the white triangle PNM according to side angle side rule. So actually, what is side angle side rule? Side angle side rule is that if you prove that two sides and the angle between them in one triangle congruent to two sides and the angle between them in another triangle, then you prove that those two triangles congruent to each other according to side angle side rule. And we proved that those two sides, that is to say PQ and PN, and also angle 2 beta in the green triangle congruent to those two sides in the white triangle, side PM and PN, and the angle between them, that is 2 beta, in the white triangle. Therefore we proved that those two triangles congruent to each other according to side angle side rule. From the fact that those two triangles congruent to each other, we will conclude that Qn equals to Nm. Qn equals to Nm according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles congruent to each other, therefore the corresponding sides, that is to say Qn and Nm, also will be equal to each other. Okay, so we can write here that Qn equals to Nm, we will join points Q and M together by a straight line. In the next step I will draw triangle MQN again in a new page. So this is the triangle Q and M. We know that Qn equals to Mn, and we also know that angle MQN, this angle MQN equals to X. So those two sides are equal to each other, therefore in front of them will be equal angles also. Therefore those two angles must be also equal to each other. So because of the fact that this angle equals to x, then this angle must be also equal to x. Okay? This is point S here. So angle MNS is an external angle of triangle QMN, and according to rule number 4, the value of the external angle MNS, the value of the external angle MNS equals to the sum of the two angles that are not adjacent to it. The two angles that are not adjacent to it are those two angles, that is to say, this angle equals to x plus x, that is 2x. So we actually found out that angle MNS equals to 2x from one side, but from the other side, we already found out that angle MNS equals to 45 degrees. So from this equation, we will conclude that 45 degrees equals to 2x. We will divide this equation by 2 and we will get that x equals to 45 degrees over 2. 45 degrees over 2 is 22.5 degrees. So we found out that the value of angle x, according to the second method, also is equal to 22.5 degrees. Okay. So now I'll summarize the lecture. Actually, we wanted to find out the value of angle x, this angle, and we found it in two different methods. In the first method, we define this angle as alpha, this angle as beta, and this angle as y. We know that the sum of the angles on one side of a straight line must be equal to 180 degrees. Therefore, if we focus on the upper side of the straight line QR at point S, the sum of the angles must be equal to 180 degrees. That is to say, (45 degrees) plus angle Y must be equal to 180 degrees. And we subtracted 45 degrees from this equation and we got that angle Y equals to 135 degrees. So we found out that this angle equals to 135 degrees. Then I presented to you the law of sines. The law of sine is true in any triangle. If we have this triangle, we know that this side is equal to A units, this side equals to C units, and the length of this side is B units. We also know that this angle A, this angle B, this angle C. According to the law of sines, A over sinus A equals to B over sinus B equals to C over sinus C. We can derive from this formula that A over sinus A equals to B over sinus B. If we divide this equation by B and multiply it by sinus A, we will get that A over B equals to sinus A over sinus B. So what is the meaning of this equation? The meaning of this equation is that the ratio of the side lengths of any triangle is equal to the ratio of the opposite angles. Okay? Then we focus on our original drawing. In our original drawing, we can create equation number 1 that states that PS over QS equals to PS over SR. Here PS over QS equals to PS over SR. Why this equation is true? Because of the fact that QS equals to SR, QS equals to SR. Here QS equals to SR, it is given us in the question. But according to the equation that we derived from the law of sines, that A over B equals to sinus A over sinus B, we will get that PS over QS in triangle PQS, PS over QS, it is actually sinus 3x over sinus alpha. This sinus 3x over sinus alpha, while if we focus on triangle PSR, PS over SR, PS over SR will be equal to sinus x over sinus beta. PS over SR equals to sinus x over sinus beta. We know that the sum of the angles in any triangle is equal to 180 degrees. That is to say, in triangle PQS, alpha plus 3x plus 45 degrees must be equal to 180 degrees. We subtracted 3x and also 45 degrees from this equation, equation number 2, and we got that angle alpha equals to 180 degrees minus 3x plus 45 degrees. Likewise, in triangle PSR, the sum of the angles must be equal to 180 degrees. That is to say, angle beta plus 45 degrees plus angle x must be equal to 180 degrees. We subtracted 135 degrees and also x from this equation, equation number 3, and we got that angle beta equals to 45 degrees minus x. So after we found out the value of angles alpha and beta in terms of x, we can substitute here sinus alpha and sinus beta in equation number 1 by the value that we found for alpha and beta. We substitute alpha and beta in this equation, equation number 1, by the values that we found for them in equation number 2 and equation number 3. We will do it here, we did it here, and we found out that sinus 3x over sinus alpha, and alpha is 180 degrees minus 3x plus 45 degrees, equals to sinus x over sinus beta, and beta is 45 degrees minus x. Okay? And according to the trigonometric identity that sinus 180 degrees minus theta equals to sinus theta, we will get that sinus 180 degrees minus 3x plus 45 degrees equals to sinus 3x plus 45 degrees. So we will change here this expression in the denominator to sinus 3x plus 45 degrees. So we did it here, and we got that sinus 3x over sinus 3x plus 45 degrees equals to sinus x over sinus 45 degrees. We cross multiply this equation, equation number 1, we receive this expression, then we multiply this expression by 2, and we got this expression. Then we use the trigonometric identity that 2 sine A sine B equals to cosine A minus B times cosine A plus B. We use this trigonometric identity in order to simplify these expressions. In our specific equation, A equals to 3x and B equals to 45 degrees minus x. So according to this trigonometric identity, 2 sine A sine B equals to cosine A minus B. What is cosine A minus B? A is x and B is 45 degrees minus x. So A minus B is x minus x, it is actually a is 3x and b is 45 degrees minus x, so a minus b is 3x minus minus x. 3x minus minus x is 3x plus x, that is 4x, and 0 minus 45 degrees is minus 45 degrees. So we got cosinus 4x minus 45 degrees for this expression, and we also must subtract cosine a plus b from this equation. According to this trigonometric identity, we also must subtract cosine a plus b. So it is cosine a is 3x and b is 45 degrees minus x. So 3x plus minus x is 3x minus x, that is 2x, and 0 plus 45 degrees is 45 degrees. So we got here cosinus 2x plus 45 degrees. Okay, then, so we finished with this side of equation number 1. Then we treated this side. Here we have 2 sine x, sine 3x plus 45 degrees. Here actually a equals to x and b equals to 3x plus 45 degrees. So we get that 2 sine a sine b equals to cosine a minus b. Cosine a minus b. So a is x and b is 3x plus 45 degrees. So it is actually x minus 3x is minus 2x, and here we have a minus b, so it is x minus 3x is minus 2x, and 0 minus 45 degrees is minus 45 degrees. So we get here cosine 2x minus cosine minus 2x plus 45 degrees, but because of the fact that cosine x equals to cosine minus x, we can change the negative sign to positive sign, and in conclusion we will get that this expression is actually cosine 2x plus 45 degrees. Okay, then we have also to subtract cosine a plus b. So it is minus cosinus a plus b. A is x, b is 3x, and x plus 3x is 4x, and 0 plus 45 degrees is 45 degrees. Okay, so here we have cosine 4x minus 45 degrees, and we have minus cosine 2x plus 45 degrees. So we will add to this equation cosine 2x plus 45 degrees, and I'll repeat again. Here we have to subtract cosine a plus b. So it is minus cosine a plus b. A is x, b is 3x, x plus 3x is 4x, and 0 plus 45 degrees is 45 degrees. So here we copy this expression here, cosine 4x minus 45 degrees. We added to this equation number 1 cosine 2x plus 45 degrees, so this will be cancelled. And also we added cosine 2x plus 45 degrees, so we have cosine 2x plus 45 degrees plus cosine 2x plus 45 degrees. We will get that it equals to 2 cosine 2x plus 45 degrees. Then we have actually here cosine 4x minus 45 degrees plus cosine 4x plus 45 degrees is very similar to the trigonometric identity that states that cosine c plus cosine d equals to 2 cosine c plus d over 2 times cosine c minus d over 2, and the expression 2 cosine 2x plus 45 degrees is very similar to the expression that cosine a plus b equals to cosine a cosine b minus sine a sine b. Okay, so here what is cosine c plus cosine d? It equals to, according to this trigonometric identity, it equals to 2 cosine c plus d over 2. And here we have c is 4x minus 45 degrees and d is 4x plus 45 degrees. So c minus d is 4x minus 4x, that is 0. And here again, cosine c plus cosine d is 2 cosine c plus d over 2. C plus d is 4x plus 4x over 2 is 4x. And minus 45 degrees plus 45 degrees is 0. So here we will get 2 cosine 4x. And we also must multiply it by cosine c minus d over 2. C is 4x minus 45 degrees. And this 4x plus 45 degrees. So 4x minus 4x is 0, and minus 45 degrees minus 45 degrees is minus 90 degrees, minus 90 degrees over 2 is minus 45 degrees, but because of the fact that cosine minus 45 degrees equals to cosine 45 degrees, we will change the minus to plus and it will be cosine 45 degrees. Okay? Then we have the 2 cosine 2x plus 45 degrees. So it is similar to the trigonometric identity that cosine a plus b equals to cosine a cosine b minus sine a sine b. Here a equals to 2x and b equals to 45 degrees. So it is 2 cosine 2 cosine a cosine b, that is to say it is 2 cosine 2x cosine 45 degrees. Okay. So here we divided equation number 1 by 2 cosine 45 degrees, and we left only with the expression that cosine 4x equals to cosine 2x minus sine 2x. We added sine 2x to this equation and then we subtracted cosine 4x. We got that sine 2x equals to cosine 2x minus cosine 4x. We know that sine 2x equals to 2 sine x cosine x. And cosine 2x minus cosine 4x, we did it according to the trigonometric identity that cosine c minus cosine d equals to 2 sine c plus d over 2 times 2 sine d minus c over 2. In this way we solved the expression cosine 2x minus cosine 4x. Here c equals to 2x, d equals to 4x. So cosine 2 sine d plus c over 2 is actually it is actually c is 2x, d is 4x, so 2x plus 4x is 6x, and 6x over 2 is 3x. And then we have to multiply it by sine d minus c over 2. So sine d minus c. D is 4x, c is 2x, so 4x minus 2x is 2x, and 2x over 2 is x. So here we have sinus x. Then we divided this equation number 1 by 2 sine x, and we got actually got cosine x equals to sine 3x, and according to the trigonometric identity that cosine x equals to sine 90 degrees minus x, we get here, we substitute cosine x by sine 90 degrees minus x, and we will get that sine 90 degrees minus x equals to sine 3x. It means that 90 degrees minus x equals to 3x. We added x to this equation, and we got that 90 degrees equals to 4x. Then we divided this equation by 4, and we got that angle x equals to 90 degrees over 4, that is to say it equals to 22.5 degrees. So we found out that angle x equals to 22.5 degrees according to the first method. Then I presented to you method 2, how to find out the value of angle x according to the second method. In the second method, we defined this angle as alpha, this angle as beta, this angle equals to 135 degrees. Then we know that the sum of the angles in any triangle is equal to 180 degrees. That is to say, the sum of the angles triangle QQS must be equal to 180 degrees. That is to say, alpha plus 3s plus 45 degrees must be equal to 180 degrees. We subtracted 45 degrees from this equation, and we got that alpha plus 3x equals to 145 degrees. In triangle PSR, the sum of the angles must be equal to 180 degrees. That is to say, beta plus 135 degrees plus x equals to 180 degrees. We subtracted 135 degrees from this equation, equation number 2, and we got that beta plus x equals to 45 degrees. We multiplied the equation number 2 by 3, and we got that 3 beta plus 3x equals to 135 degrees. This is according to equation number 2, but according to equation number 1, alpha plus 3x equals to 135 degrees. So we can say that equation number 2 equals to equation number 1, and this is equation number 3. that states that equation number 2 equals to equation number 1. And we subtract that 3x from this equation number 3, and we got that alpha equals to 3 beta. Alpha equals to 3 beta. Then we made a construction from point Q. We drew a straight line to PR in such a way that this angle equals to x. And so actually triangle QMR is an isosceles triangle because it has two angles that are equal to each other. We join the points M and S together by a straight line. MS is the median to the base, and the median to the base, it is actually also perpendicular to the base. That is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees. And then I presented to you rule number 4. According to rule number 4, an exterior angle of a triangle is equal to the sum of the angles that are not adjacent to it. So what is the meaning of rule number 4? The meaning of rule number 4 is that if we have this triangle ABC, angles alpha, beta, and gamma are defined as the interior angles of triangle ABC, and angle SAB is the exterior angle, and according to rule number 4, the value of the exterior angle SAB equals to the sum of the angles that are not adjacent to it. Those two angles are not adjacent to it, and the sum of those two angles is actually alpha plus beta. So the value of the exterior angle SAB is equal to alpha plus beta. We can implement rule number 4 in our drawing, because we have in our drawing the exterior triangle QMR as those two angles and this angle that is are defined as interior angles. Angle PMQ is defined as exterior angle. And according to rule number 4, the value of the exterior angle PMQ of this angle is equal to the sum of the two angles that are not adjacent to it. Those two angles are not adjacent to it, and the sum of those two angles is x plus x. That is to say, the value of the exterior angle PMQ equals to 2x. So those two angles are both equal to 2x, and therefore, in front of equal angles in the triangle, there are equal sides. That is to say, PQ equals to QL. Then, from point P, I drew perpendicular to QM and extended the perpendicular until it touches QS at point L. We define the touching point between the perpendicular to QM as point L. Then we proved that those two angles are similar to each other. Those two angles are both right angles, they are equal to each other. Those two angles are also equal to each other, they are both equal to 2x. And those two angles must be also equal to each other according to third angle theorem. So if one angle is theta, then the other angle must be also equal to theta. Okay? And from the drawing, you can see that theta plus theta equals to alpha plus beta. That is to say 2 theta equals to alpha plus beta. According to equation number 3, alpha equals to 3 beta. So we can substitute alpha by 3 beta in this equation, and we will get that 3 beta plus beta is 4 beta equals to 2 theta. We divided this equation by 2, and we got that theta equals to 2 beta. So we can write here that theta equals to 2 beta, and also here theta equals to 2 beta. From the drawing, you can see that angle LPS equals to theta minus beta, that is actually beta. Okay, and also here 90 degrees minus angle PSN must be equal to angle MSP, that is also 45 degrees. So we proved that triangle PNS, this triangle, the green triangle, can go into the white triangle, triangle PSM. Why they can go into each other? Because first of all, those two angles are equal to each other, they are both equal to beta, and we have those two angles that are also equal to each other, they are both equal to 45 degrees, and we have the common side PS. So we prove that those two triangles can go into each other according to side angle side rule, and from this we can conclude that ASM equals to PS. Then I draw triangle MSN in a new page, and we have this triangle. This is a right triangle, MS equals to SN, and because of the fact that MS equals to SN, those two triangles must be equal to 45 degrees. Okay? And we prove that those two triangles can go into each other. The green triangle can go into the white triangle. Why? Because first of all, we know that PQ equals to PM. Those two angles are equal to each other, and we have common side PM. So we prove that those two triangles can go into each other according to side angle side rule. Therefore, MN equals to QN. So I draw triangle QMN again in a new page, and we know that QM equals to QN. We know that this angle MQN equals to X. Angle MQN equals to X. And also QN equals to MN. In front of equal sides in the triangle there are equal angles. So those two angles must be equal to each other. And because of the fact that this angle equals to X, this angle must be equal to X. And according to rule number 4, the value of the exterior angle M and S is equal to the sum of the two angles that are not adjacent to it. The two angles that are not adjacent to it are those two angles. That is to say, the value of triangle M and S is X plus X, that is to say 2X. From one side, the angle M and S equals to 2X. But from the other side, we have already found out that angle M and S equals to 45 degrees. So from this equation, we will derive that 45 degrees equals to 2X. We divided this equation by 2, and we got that angle X equals to 45 degrees over 2, that is to say it equals to 22.5 degrees. So in both methods, we found out that the value of angle X is 22.5 degrees. Okay, thank you very much.